Okay, we are at section 4 of the midterm review, and this is going to cover the sum and difference identities for sine and cosine. So our problem is to find the exact value of the sine of 5 pi over 12. First off, 5 pi over 12 is in radian form. So what we'd like to do first is change it into degrees. So I'm going to rewrite 5 pi over 12. To change this into degrees, I'm going to multiply by 180 degrees over pi. The pi's are going to divide out, pi over pi, that crosses out. And then we are going to have 5 times 180 divided by 12. And we can definitely plug that into the calculator, and that will give us 75 degrees. So the sine of 5 pi over 12 is the same as the sine of 75 degrees. So let's go to our unit circle and take a look at it for just a minute here. So here's our unit circle, and as you can see, let's make it so that we can see a little bit more of it. Okay, so we can't see the whole thing, but this is good enough. As you can see, 75 degrees is not on the unit circle. We know that it's somewhere between 60 and 90, but it's just not here. So what we'll have to do is use a sum or difference to find the sine of 75 degrees. Now, in order to do that, let's write sine here, go back to the unit circle. We're going to have to find two angles that either add up to or subtract to get 75 degrees. So two obvious ones are 45 and 30. So let's go back here, and we can write 45 degrees plus 30 degrees. Now, there's many different combinations that you can use. I don't want you to think that the only two angles that we can use are 45 and 30. We can also use 135 minus 60. So we can write that. So the sine of 135 degrees minus 60 degrees, this will also be 75. Now, just because we have this written down first, we are going to stick with that. So the sine of 45 plus 30. So I'm finding the sum identity for sine. So from our blue sheet of paper, I'm going to write sine of A plus B. Remember, A stands for the first angle, and B stands for the second angle. All right, so from our formula sheet, we know that the sine of A plus B is going to be the sine of A times the cosine of B minus the sine of B times the cosine of A. So there are four things that we have to find. We have to find the sine of A, the cosine of B, the sine of B, and then the cosine of A. And I actually wrote this wrong right here. That should be A plus. Sorry about that. When it's sine, whatever operation sign is here, this is the same operation sign. So let's go through this. So sine A is the first angle, is going to be the sine of 45 degrees. Let's go back to our unit circle. Let's look at 45 degrees. Now, at 45 degrees, the x-coordinate and the y-coordinate are the same, so it's almost pretty difficult to make a mistake if you're trying to find sine and cosine. But we remember that the x-coordinate is the cosine, the y-coordinate is the sine, so we know that the sine of 45 degrees is root 2 over 2. Next up, cosine of B, so the cosine of not 45, but the cosine of 30 degrees. So let's go to 30 degrees on the unit circle. At 30 degrees, the coordinates are radical 3 over 2, comma 1/2. The x-coordinate is the cosine, so the cosine of 30 degrees is radical 3 over 2. 1/2 would be the sine, which we're going to use in just a minute. So the cosine of 30 degrees, I will put radical 3 over 2. Next up, sine B. So sine B is going to be the sine of 30 degrees. I'm not going to go back to the unit circle because we just said this is 1/2. And finally, the cosine of A is going to be the cosine of 45 degrees, and we know that is root 2 over 2. So since I have room over here, I'm going to go ahead and plug in. So first, sine A, we know that is root 2 over 2. Cosine B is root 3 over 2. Plus, sine B is 1/2. And cosine A, last one, is radical 2 over 2. So radical 2 over 2 times radical 3 over 2, we multiply straight across. Now, the denominator, 2 times 2, is just 4. When you multiply two radicals, you combine the radicals and multiply the numbers that are inside. So this becomes radical 2 times 3, which is radical 6. Plus 1/2 times radical 2 over 2 is simply radical 2 over 4. And this is actually your answer. Now, I want to make sure that you're aware of the different forms of the answer. I can rewrite this as radical 6 plus radical 2 over 4 because they have the same denominator. I can't add what's in the numerator, though, because these are actually not like terms. And one other form, it can look like radical 2 plus radical 6 over 4. All three of these mean the same thing, so please keep that in mind. Okay, next up, we're going to look into finding the exact value of the cosine of 195 degrees. So once again, 195 degrees is not on the unit circle. We'll have to find two angles that either add up to or subtract to get 195 degrees. So let's go to our unit circle. And as usual, there are many different combinations that we can use. So mostly people like to use, they see first 135 and 60. So 135 plus 60, that definitely adds up to 195. So 135 plus 60. And let's just see if there's anything else. Another pretty popular combination is 150 and 45. So we can say the cosine of 150 plus 45. And like I said, there's a bunch of different combinations we can use. So let's go with this first one, cosine of 135 plus 60. So that's a sum identity for cosine, so I'm going to write the cosine of A plus B. From your blue formula sheet, we know that this is going to be the cosine of A times the cosine of B. Now, with cosine, whatever operation sign is here, the opposite goes here. So minus sine A sine B. Okay, so once again, we have to find four things: cosine A, cosine B, sine A, sine B. A stands for the first angle, which in this case is 135. B stands for the second angle, which in this case is 60. So first, cosine A is going to be the cosine of 135. And let's look at our unit circle for just this one particular example. At 135 degrees, the coordinates are negative radical 2 over 2, comma, positive radical 2 over 2. As always, the x-coordinate is the cosine, so negative radical 2 over 2. The y-coordinate is the sine, positive radical 2 over 2. So let's go ahead and put negative radical 2 over 2. Next up, cosine b, which is the cosine of 60 degrees. And from our unit circle, we know that is 1/2. Next up, sine of A, which is the sine of 135. We just said that is positive radical 2 over 2. And finally, the sine of 60 degrees, which I kind of went backwards there a little bit, the sine of B, so that will be positive radical 3 over 2. Okay, so we are ready to plug in. First up, cosine A, parentheses, negative radical 2 over 2. Cosine B, 1/2, minus sine A, radical 2 over 2, times sine B, radical 3 over 2. Negative radical 2 over 2 times positive 1/2 is negative radical 2 over 4. Negative times radical 2 over 2 times radical 3 over 2 gives us negative radical 6 over 4, which can also be written as negative radical 2 minus radical 6 over 4, which can also be written as negative radical 6 minus radical 2 over 4. Okay, so next up, we're going to go over 19 and 20. Now, 19 is not written, it's fine, but I want to change this so that it's consistent with what is on your blue sheet of paper. So we're going to rewrite sine 335 and then cosine 155. But these two I'm going to switch because this is how it's written on your formula sheet, and it will be like this on the test as well. So this says find the exact value, but this time it gives us the expansion, like expanded out, written out. So what we have to do is work backwards to figure out what it starts out as. The first thing we want to do is figure out if this expression comes from sine or comes from cosine. So we are going to go back and take a look at the identities. Now, if you notice, for cosine, whenever you have a cosine identity, so that'll be the cosine of A minus B or the cosine of A plus B, you start off with two cosines. But when you have a sine identity, you start off with a sine and then a cosine. If we go back to our problem, we have a sine and then a cosine, so we know that this has to be a sine identity. So I'm going to write sine, and then I'm going to write the two angles, 335 and then 155. The second thing we have to do is figure out if this is going to be a plus sign or if this is going to be a minus sign. So let's go back to our identities once again. Now, remember, when it's sine, whatever this operation sign is the same as that. If you look, minus, minus, plus, plus. So let's go back to the problem. We have a minus there. Therefore, we have to have a minus right here. Now, the next thing we're going to do is do 335 minus 155. That is 180 degrees. So what we have to do now is find the sine of 180 degrees. Let's go back to our unit circle. So here's our unit circle. At 180 degrees, the coordinates are -1, 0. Remember that the x-coordinate is cosine, the y-coordinate is sine. Therefore, our answer has to be 0. Let's go to the next problem, number 20. cosine of 85, cosine of 25, plus sine of 85, sine of 25. First thing, we have to determine if this is sine or cosine, so let's go back to our identities here. And remember that cosine starts with two cosines, as this problem does, so therefore this has to be a cosine identity. And I'm going to put parentheses and then put 85 and then put 25. The next thing we have to determine is if a plus or a minus goes in here. So let's go back and look once again. Remember that with cosine, whatever this operation is, it's going to be the opposite. Like that's a minus, that's a plus. That's a plus, that's a minus. So let's go back to our problem. If that's a plus, then that means this had to start out as a minus. So the cosine of 85 minus 25 is 60 degrees. So we have to find the cosine of 60 degrees. Let's go back to our unit circle. And at 60 degrees, the coordinates are 1/2 comma radical 3 over 2. We know that the x-coordinate is the cosine, so our answer is 1/2. Okay, next up, we have problem 21 that says the sine of 75, but I'm actually going to skip here to problem 22. And this says the sine of negative 75. Now, in order to find the sine of a negative 75, we need to find the sine of 75 degrees. And we've actually done this already, and this was done in problem number 17. We found that the sine of 75 was radical 6 over 4 plus radical 2 over 4. So let's go back and write that in. So the sine of 75 is radical 6 over 4 plus radical 2 over 4, or we can always write this as radical 6 plus radical 2 over 4. If we know the sine of 75, we also know the sine of negative 75. If you know the sine of the positive angle, the sine of the negative angle, all you do is take the opposite. So if the sine of positive 75 is positive radical 6 plus positive radical 2 over 4, the sine of negative 75 is negative radical 6 minus radical 2 over 4. Now, the good thing about this is that as long as you know the sine of the positive angle, you know the sine of the negative angle. But if you get the sine of the positive angle wrong, then you will also get the sine of the negative angle wrong. So this concludes section 4 of our midterm review. There is one remaining section.